Okay, so today we're going to do a review of all the different things we've learned. We've talked about transformations, vertex form, standard form, and now we know how to do factored form. And so I'm just going to walk you through this. I may or may not be able to be here in class today. Let's just start by putting our names on the paper. You all have this sheet in your student journal. And for 1, 2, 3, we're going to graph it. We're going to label the vertex. We're going to label the axis of symmetry. We're going to find the maximum or minimum, which, as we know, is the vertex. And then we're going to also do the domain and the range. So we'll be talking about increasing and decreasing. We haven't yet, but basically it means where the line is going up and where the line is going down. So it's not going to be difficult. Please have another sheet of paper ready to do your work on here. This is not enough room. It's basically just enough room for the graph. So we'll start with number 1. We've got a function that's equal to x plus 1 squared. If we do this with transformations, then this tells us that it's going to move to the left 1 unit. So if our vertex was 0, 0, okay, then this is going to be the shape of a quadratic, but the vertex is going to be negative 1, 0. So our vertex will be negative 1, comma, 0. This could also look like, if you put it in vertex form, there's an invisible 1 here. And then your HK, right, is 0. So this is your H, this is your K, negative 1, 0. So we have the vertex, the axis of symmetry is x equals negative 1. So we can go ahead and put that on there, and negative 1. And then you can just use your ID card or a small ruler, anything straight. We know that the vertex is like this. And then the maximum or minimum, well, our minimum is going to go here. We know it's positive, it's going to open up, so that is the minimum. We'll just go ahead and mark it on our paper, minimum. Now, in order to graph it, it is just like the parent function. So from the vertex, it's going to be 1, 1, 2, 4, and that's all that's going to fit on the graph. Again, since it's symmetric, this is 1 over, this is 1 over, away from the axis. This is 2 over, this is 2 over. Of course, if we were in a, if we had a bigger graph, we might make it, you know, we'd also do 3, 9. But for right now, that's what it looks like. Make it a happy graph. And you can, like that. Now there's a couple more things we haven't listed, right? We haven't done the domain and the range yet. So the domain, as you know, pretty much almost every quadratic is going to be negative infinity to positive infinity. It is the range that we need to pay attention to. This, going negative to positive, remember the number on the left is the negative. So it's from the lowest point, that is where y is equal to 0. So it's 0, and then it goes all the way up, positive infinity. Now the increasing, decreasing part is basically where the graph is going up. So we're going to call this going up. We're going to call this going down. So think positive slope and negative slope. So it's increasing from 0, and we always do it along the x. It's increasing from 0 up to infinity. That'll be our interval notation. And it's decreasing. Again, remember we go left to right. So it's decreasing from negative infinity to 0. Okay, so we did vertex axis, we did minimum, we did domain and range, and we did increasing, decreasing. Great. So now you can go ahead and continue on 2 and 3, exactly like that. Make sure you move down on your paper. I'm going to go ahead and keep working. If you feel comfortable doing all of this on your own, go ahead and keep working individually. I'm just going to continue because I may or may not be able to be there today. So I have y equals negative 2, x minus 4 squared minus 5. So right off the bat, I know this is vertex form. And so my vertex is 4 for the x and negative 5 for the y. That means my axis of symmetry is x equals 4. I also know that it's going to be a little, let me move this up. It's going to be just a little bit narrower because that 2 is going to stretch it a little. And I know that that's going to turn it upside down. So if I have the axis of symmetry at 4, I'll go ahead and draw that now. 1, 2, 3, 4. There's our axis of symmetry. And my vertex is at 4, negative 5. 1, 2, 3, 4, 5. Holy cow, that's going to go way off the graph. Because this is negative, so it means it's going to go like this. Okay? That's going to be the maximum point. So you can just sort of sketch it like that. It's going to go off the graph. But we will label all of our points, okay? This, then, because it's upside down, is a maximum. So we'll call that a maximum on our paper. Okay, we're going to look at our domain and range here. Domain is always negative infinity to infinity for basic quadratics. And it's our range that is important here. So we want all the negative y's, but no higher than negative 5. It doesn't get any higher than negative 5. So it goes from negative up to positive, and that is included. So we do the closed square bracket. And then last, we're going to mark where it's increasing and decreasing. So again, think of this as the direction that slope goes. This is more like positive, and this is more like negative. So increasing interval is going to go left to right from negative infinity up to 4. We're going to go along the x-axis up to positive 4, and then decreasing. Well, we're not actually going to include it right at 4. Sorry about that. And then let me fix that. Because it's exactly flat at that point, so that's an interval. And then it's decreasing from this direction. So you're going to go from 4, where x is 4, to positive infinity. And that is, did we get all 4? So we did the vertex, the symmetry, the maximum, we did the domain, we did the range, we did the increasing and decreasing. Okay, now we can go on to number 3. Paper here so I can fit it together with the camera. Okay, so now number 3 is in standard form. So it's the same steps. We're just going to make it a little different. This says t of x, so it's some kind of maybe time or travel or whatever. So remember, in standard form, the first thing we have to do is identify a, which is 3 over 2, b, which is negative 3, and c, which is negative 1. So in order to find our vertex, it'll be where we find our axis of symmetry first. That'll be our x. Then we'll plug it in to get our y. So if you remember, the axis of symmetry is x equals negative b value over 2a. So that's going to be the opposite of negative 3 divided by 2 times a, and a is 3 over 2. So the opposite of negative 3 is positive 3. 2 times 3 over 2 is 3. And so we end up getting x equals 1 as our axis of symmetry. We'll just do a of s. But that means that this vertex is 1. So now to get the y, we say it's a t. So what is t of 1? So we plug in the 1. 3 over 2 times 1 squared minus 3 times 1 minus 1. And I don't have my calculator with me, so let me just figure this out. So it'll be 1.5 minus 4. Negative 2.5. I think it might be negative 2.5. What I should do here is pause and just do this. So checking with my calculator. It is negative 2.5. So my vertex is negative 2.5, and my axis of symmetry is 1. Let's go ahead and put that on there. As our symmetry 1, 2, 3, 4, 5, just sort of dash it along there. And let's put our vertex on. So it'll be at 1, and then negative 1, 2, and then put the dot right there. That'll be our vertex. We know that it's going to open upward because this is positive. So it'll be this way, which means this is the lowest point, and therefore we call it a minimum. Okay, so we've got our vertex. We've got our axis of symmetry. We've got our minimum. Now we have to do our domain, our range, our increasing, and our decreasing. So domain is always the same, pretty much. It's going to be negative infinity to positive infinity. The range then, well, I don't have any points or anything. Let's figure out what our points are. I can tell already, if it goes up, the range is only going to go up to this point. Okay, the range goes up to this point. So it'll be negative infinity up to, and that is negative 2.5, and we'll be including that. So that'll be this way. So then, in order to graph it now, we actually need to pick a few points. So let's do a little XY chart over here. Remember, the points we're going to pick are going to be on either side of the 1. So you'll want to pick 0, you'll want to check what 2 is, and then at least one more, so maybe 3 or negative 1. So we'll pick 0, and we'll pick 2. And let's do 3 just for good measure. At this point, you're going to put in calculator work. So you put the 0 in here, you get 0 minus 1. Cool. This one is, remember, symmetric, so that's also going to be negative 1. So when I put in 3 into this, again, grab your calculator, so it's going to be 9 minus 9 minus 1. Well, that doesn't make sense. Oh, I got 3.5. Okay, 3.5. That is good. And of course, that'll give me another point. So let's put those on the graph, if I did that correctly. Okay, so 0, negative 1 is a point. 2, negative 1 is a point. 3, and then 3.5. 1, 2, 3.5 is a point. And if this is 2 away from here, it's symmetric, so I get another one over here that's 2. And that actually does look like a nice little graph. Okay. Give it a smile. Connect it. Okay. The only and then we'll have to do increasing and decreasing. This one I didn't pick points just because it was off the grid, but I should have also picked points there. And then the last part, increasing, decreasing. So if you start down here at the bottom, it's going up from here. That's your increasing. And then from here, it's going down to the bottom. So that's your decreasing. So increasing interval goes from 1 to infinity. We're not including 1 because it's actually flat right there. And then decreasing, we're going to go from negative infinity all the way up to 1, going along the x. And always, as always, left to right. So we're done with number 3. Yay! All right. Yesterday we did this on factoring, or graphing in factored form. So let's see how much of that sunk in. Okay. Of course, I hope all of it. I'm changing my paper here so that I can do a little bit more. And you can stop the video and go back if there's any step you didn't get. I'm going to try to lock this. It keeps trying to focus. Okay. So we're just going to graph, do the x-intercept, vertex, and axis of symmetry. So not quite as much work as those, but again, we'll do number 4 on our paper. And fx equals 4 times x plus 4 times x minus 3. These are x-intercepts. And so what we want to do is solve using the zero product property. Okay? Remember, basically either this is 0 or this is 0. So you're going to get both of them as possibilities. They will both be crossing the x-axis. So here, x would have to be negative 4, and here, x would have to be positive 3. That means that on our graph, we're going to put dots at 1, 2, 3, and 1, 2, 3, 4, negative 4. Those are our x-intercepts, if you recall. The axis of symmetry is going to be directly in the middle of it, right? So axis of symmetry will be in the middle of these 2 points. So you basically figure out the middle and divide by 2, right? So negative 4 plus 3 divided by 2 gives you negative 1/2. So the axis of symmetry is x equals negative 1/2. I'm going to go ahead and add that to my graph here. That looks right. 3.5, 3.5, definitely in the middle. Now I need to get the vertex. I need to know which way it's going. I see it's going up. It's positive. So my vertex is going to be down here somewhere, right? So I've got my x of my vertex. Now I have to get my y. So I'm going to do f of negative 1/2. Plug it in. So do 4 times negative 1/2 plus 4 times negative 1/2 minus 3. Again, just grab your calculator to do that work. 4 times. Okay, and I get negative 49. Holy cow. Negative 49? That's way off. But that makes sense, because look, it is stretched by 4. It's going to be super skinny. If this is the vertex, and I'd have to go in each time I go in, right? I got to go. Then it makes sense for the vertex to be way the heck down here. In fact, it'd be really way the heck down here. And so that'd be negative 49. So all we can do really, because it's such a small graph, is we can figure out the y-intercept and maybe a couple other points, but still it's going to be, way down there. So we could figure out the y-intercept. Another thing we could do is Just check and see what 2 is, and check and see what 1 is. But 0 is going to be much closer to negative 49. So if you put 0 in here, okay, let's just figure out what f of 0 is. It's 4 times 0 plus 4 times 0 minus 3. So f of 0 is 4 times 4, that's 16, times negative 3. So the y-intercept, right, where x is 0, is negative 48. We can't draw that one either. So I think because my vertex is way, way, way down here, let's just sketch it the best we can. We have labeled the, did I get my, oh yeah, so my vertex I forgot to write down. Okay, so my vertex is negative 1/2 for the x value and negative 49 for my y value. Because I'm following the directions. I got the vertex, I got the x intercepts right here, and I've got the axis of symmetry. So all of those are labeled, and if you're going to sketch it, it's going to be super skinny, like that. Just put some dots. That means it continues way over here. It's going to continue up. It doesn't fit on the graph, but that's what we have. Okay, so now on your paper, you can move down to number 5. We'll do this one together. Same thing here. Okay, so number 5. I'm going to graph the function. So my function is negative 7x times x minus 6. Now, this is factored. It's just not 2 binomials. This is a single term. We call that a monomial and a binomial. But your zero product property is going to hold exactly the same. So you'll figure out what the x-intercepts are by setting it equal to 0. So either this is 0 or this is 0. So over here, what would it take for negative 7x to equal 0? Well, x would have to be 0. What would it take for x minus 6 to equal 0? Here, x would have to equal 6. So these are my 2 intercepts. My intercepts are 0, 0 and 0, 6. No, the other way around. 6, 0. Whoops. It's the y that is the 6, 0. Okay, so I can try to put these on the graph here. These are my intercepts. I know my axis of symmetry is going to be in the middle. So it's going to be 0 plus 6 divided by 2. Okay. So x equals 3 is my axis of symmetry. And then the other thing I'm going to find is my vertex. So let me just go ahead and put what I can on the graph right now. We'll do the vertex in a second. First of all, 1, 2, 3, 4, 5, 6 will be out here, and 0, 0 will be here, right? I also know x equals 3, which happens to be directly in the middle, is going to be my axis. So let's do this. Draw it in the middle. Okay, let me do these. Right, they're both 3 away. Now, I'm going to just check before I do the vertex. What does this tell us? It tells us it's going to go upside down. So my vertex, so that means that these 2 points where they cross, it's going to be going this way somehow. So my vertex will probably be up here. It's just one thing you need to look at before we figure this out. Okay? So your vertex then will be where you plug in x equals 3 to your function. So f of 3, again, this is calculator work, equals negative 7 times 3 times 3 minus 6. Again, we're plugging it in right here. Move that up just a little bit. And f of 3 is giving me negative 21 times negative 3. Wow, that's a lot. Okay, so negative 7 times 3 times 3 minus 6 is another 3, negative 63. Whoa, another just massive number. Okay, but that means my vertex is 363. It's going to be way, way, way up here if I had a huge graph. Okay, so really all we're going to be able to do on this graph is make sure these go down. It's going to be a super skinny one because 7 will make it very skinny. So it'll be way up here. This is the middle, right? So it'll be somewhere way up here. Try to make it straight as possible. Okay, so your graph's going to look really weird, but that's okay. That's what we got. 2 super skinny graphs. And then I'm going to leave number 6 because this video is already 26 minutes. I want you to draw this picture. Okay? Draw a picture, label everything. Here is your function. In other words, when it says you're going to draw this path, so you'll draw a picture and here's your function. Do your best. Explain the answer. I call this the Babe Ruth problem. And I will be checking this tomorrow.